Hello, welcome to the Chapter 7 review warm-up. I want to go through this step by step just to make sure that you all are okay with these problems as they will prepare you for your test next week. So number one, your instructions are to evaluate the expression without a calculator. What does that mean? That means I don't want you to use a calculator at all when you do this problem. Write our answer in decimal form, so not scientific notation, but in decimal form. So I'm looking at this, and I basically would like to start this problem by doing the like terms, or the easier terms first. So I'm going to do some grouping here. This 2 and the 3. I'm going to multiply those two together, and then I'm also going to multiply the 10s together. So I'm going to multiply 10 to the negative 3 times 10 to the 7th as well. So 2 times 3, that's kind of an easy one. That's going to give me 6. Times, now I have 10 to the 3rd power times 10 to the 7th power. This reminds me of a property. A to the m times a to the n is equal to a to the m plus n. Remember, when you're multiplying and they have the same base, I would add the exponents. Just like for this one, I'm multiplying and they have the same base, so I'm going to add these two exponents. I'm going to have 10 to the negative 3 plus 7 will give me 4. That's not a 4. Will give me 4. Just make sure you're paying attention. Okay, this is not in decimal form though. It's actually scientific notation because there's only one number in front of the decimal point. So when they don't give me a decimal point, though, remember it's after, and then this is a positive 4. So I'm going to move this over 1, 2, 3, 4 times to the right, filling in these little loops with zeros. That gives me 60 thousands. 1, 2, 3, 4. 1, 2, 3, 4. And that is box-worthy. Similarly, for division, if I'm trying to find this quotient, I want to group these two together. So 8.8 divided by 1.1. If I didn't have a calculator, if I wasn't sure about it, I could show my work. 8.1, 8.8 divided by 1.1. Remember, you do move the decimal point over. So how many times does 11 go into 88? 8 times. Now, I'm doing 10 to the 5th divided by 10 to the 3rd. Well, we have a quotient property, which tells me that a to the m divided by a to the n is equal to a to the m minus n. So subtract your exponents. 5 minus 2. 5 minus 2 is cubed. Going to give me a decimal point here, so I'll put it at the end and move it over 1, 2, 3 places. So that gives me 8,000. Very good. So for this one, horrible mistake is going to be to try to multiply this out first. Instead, I want to distribute this exponent because this is similar to a b to the m, which gives me a to the m, b to the m. So if I distribute this exponent here and then to this one, I'll have 2 to the 3rd times 10, negative 2 times 3 to the negative 6. To the 3rd, I like that number. It's 2 times 2 times 2. So 4 times 2, that gives me 8 times 10 to the negative 6. Now this exponent is negative, so instead of going to the right like I did for these two, I'm going to go to the left. Decimals at the end always, if they don't give me one. So 1, 2, 3, 4, 5, 6, and I'll fill in the rest with zeros. 0 0.1, 2, 3, 4, 3, 4, 5. 1, 2, 3, 4, 5, and then 8. That is box-worthy. All right, number 4. The value of a car is $25,000 when it is purchased. That seems important to me. It depreciates. That means depreciate. What does that mean? It means it's decreasing in value. That means I'm going to subtract for that one. At a rate of about 15% annually. Write an exponential model. That's important because I know that means a special formula for the value of the car using t for the number of years. So when they say, let's try to interpret some of this, an exponential model. So this is y equals a times 1. Now it's depreciating, so I'm going to subtract that rate each year to the t. Now I need to find out some important things. Well, I I'm looking for a model for the y. The a is your initial amount. That's the amount that you're starting off with. So this car starts off at being worth $25,000. Then we're subtracting its value by 15% every year annually. So the thing is, yes, this is the r in the equation, but remember you have to move the decimal point over twice in order to make it a decimal instead of a percent. So r equals 0.15. To the t, that's the number of years. I don't know what that is, so I'm just going to leave it as a t. So y equals 25,000 times 1 minus 0.15 is 0.85 to the t. This is a model. That's all I need. I could use this very same equation if I wanted to know the value of the car after 5 years, after 10 years, after 1 year, and I would be done. Okay, now, a little bit of a confession for you all. Looking at this problem, each graphing problem is worth 8 points. Each kind of refers to the fact that there probably was more than one on last year's test, and 2, they were worth 8 points each thing. Kind of puts me in a position where I'm going to tell you, I copied and pasted these problems from the test that I used last year. From year to year, I changed the numbers, so this will be a really, really good preview for you, so that you can kind of be able to see, do I know what I'm doing, and can I do it right on the test? So, for our fifth and final problem, we are given the function y equals 1/3 to the x, and they're asking us to do the following. Number 1, complete the table. So, I like to pick the easiest number that I can find from here to here. To me, I think 0 is easy because anything to the 0 power is 1. Anything to the 0 power is 1. Now, the next easy number for me is putting this exponent to the first power. So what's 1/3 to the first power? Well, that's just 1/3. 1/3 to the second power. Well, that's 1/3 times 1/3, which equals 1/9. Now what we like about this, and this only works because there's not a number in front of here, is that for the opposite sides, or for the negative sides, I just need to flip them. So this is 1/3 flipped is 3, 1/9 flipped is 9. Looking good so far. So this would be worth 1, 2, 3, 4, 5 points. I'm going to get a point if I can draw my points correctly. So I know this is -1, this is -2, that's 0, 1, and 2. I think I can go by ones. I think I have enough. 4, 5, 6, 7, 8, 9. I do. So -2, 9, -2, 9, -1, 1, 2, 3, 0, 1, 1, 1/3, it's about here, it's about a third, and then 1/9, even closer to 0. Now remember what we talked about. My graph is going to approach the asymptote, which would be y equals 0, but it's not going to touch it. It's going to approach it, but it's never going to touch it. If you remember, when you're looking at the example of my arm, I can get super duper close to where I can feel my arm hairs. That's kind of a good HT, so it's a little too much information for you. But I'm not touching them. Close, super duper close, without actually touching it. That's what this line is going to do. So let's go ahead and we can connect our dots. And there we have it. So it's going to decrease exponentially. Make sure that it's rounded off and that you kind of just fill up the whole graph space if you can. Okay, the next thing that they ask me about though is my domain and my range. Domain, remember, is your x value. So looking at it from left to right, there really aren't any gaps in this. It's going to just keep on going forever all the way out to the right, and it's going to go forever all the way out to the left. So what that means is that my domain is all real numbers. There's a symbol for that. The symbol for all is an upside down capital A. Real numbers is like a capital R with an extra line. Do I care if you use a symbol? Not so much. If you just write all real numbers for your domain, because domain is your x values going from left to right, then you're all good. Now your range, that's when you want to look at your y values. Remember, the y value is looking at it from up and down. Now I'm looking at this picture and it looks like it's everything from here on up. Everything from here on up. So, well, where is here? 0. It's everything above 0. Does it equal 0? No, because of that asymptote. Remember, that's when it gets really close to your arm, for example, but it doesn't touch it. So it's not equal to 0, but it's everything above it. Some people will say all of your positive numbers. And then others would just say it's everything that's above where y equals 0. So everything greater than 0. Y greater than 0. I'm good with either one of these. I typically will use this one though. Okay, one quick thing before I let you go. Let's make this a side note if you could. Side note. Side note. What if you had y equals negative, let's say, 3 to the x. Y equals negative 3 to the x. And then we know we use our handy dandy xy table when we use negative 2, negative 1, 0, 1, 2, which is great. All fun and games. And we know that it's easiest to plug in 0. However, this negative sign, kind of a troublemaker, so I'm going to deal with this and show my work. This is like saying y equals negative 3 to the 0. Okay. Now, this is what is getting the 0 exponent. Let me rephrase that. This part only has a 0 exponent. So this is like negative. What's 3 to the 0 power? 1. So the answer for this one is actually negative 1, because this negative sign is still there. Similarly, this is like saying negative 3 to the first power. Negative, well, what's 3 to the first power? 3. So for this one, it would be negative 3. The next one, negative 3 squared, which would be negative 9. Okay, what about the other side, though? These negative exponents. Typically, I can just flip those. Let's see if it works. Negative 3 to the negative 1. Negative, well, 3 to the negative 1 is 1 over 3. So we can flip that one. And then negative 3 to the negative 2 is negative 1 over 9, so negative 1/9. Cool. So now the main difference here that I want you to see is when you graph it, this would be like 1, 3, 9, boom, boom, boom. Then it would be more, pretend like I hit that, more like this instead. So your domain is always going to be all about numbers, but for this one, your range is going to be y less than 0 because it's everything below that line. All right, well, thank you very much for joining me. Please begin working on today's assignment.